Hi everyone, in this video we are going to talk about the chain rule. By using the chain rule, what we have to do, first we have to take the derivative of the outer function by keeping the inside function untouched. Then we multiply by the derivative of the inside function. For example, if my function is like this, d by dx of fx of the power n, then by using the power rule, you have to bring n in front of the derivative. So we have n times f of x to the power n minus 1. And after that, we have to differentiate the inside function f of x. So the derivative of f of x will give you f dash of x. Suppose if my function is f of g of x, then what I do? I have to take the derivative of f. So that will give you f dash of g of x. Then multiplied by, we have to differentiate the inside function, which is g of x. So the derivative of g of x will give you g dash of x. Let me show you some problems so that you will understand clearly. Find the derivative of y equal to x power 3 plus 2 the whole squared. So the derivative of y will become dy by dx, or I can say y dash is equal to, so here the power is 2. So let me bring the power 2 here, keeping the inside term as it is, that is x power 3 plus 2. Then whole power 2 minus 1, which is 1, multiplied by the derivative of the inside function. So here x power 3, the derivative of x power 3 will give you 3x power 2. The derivative of 2 will be 0. So then I have to multiply these two values. So 2 times of 3 will give you 6x power 2, keeping this term here, x power 3 plus 2. If you want, you can multiply this also, or you can leave it, no problem. Question number 2, find the derivative of y equal to 4 times x power 2 minus 2, sorry, x power 2 minus 1 the whole square. So as usual, this 2 will come front. So 4 multiplied 2 will give you 8. Then keeping the inside function as it is, x power 2 minus 1 multiplied by, now differentiate the inside function. So we have x power 2. So the derivative of x power 2 will give you 2x. Now if I multiply this number and this number, that will give you 16x x power 2 minus 1. As I told you before, if you want, you can multiply or you can leave it as it is. Example number 3. Find the derivative of the function f of x equal to 1 over 2x minus 1 the whole square. So since my x is in the denominator, before differentiate, let me rewrite the given function. So take this to the numerator. So that will give you 2x power 2 minus 1, and the exponent will become minus 2. Now use the same idea. So minus 2 will come front. Then we have to keep the inside term as it is, that is 2x power 2 minus 1. Then we have to take minus 1 in the power, that is minus 2 minus 1 will give you minus 3, multiplied by the derivative of the inside term, that is the derivative of 2x power 2 will give you 4x. The derivative of minus 1 will give you 0. So we have left with only 4x. Then I can multiply this and this. So minus 2 times 4x will give you minus 8x divided by this one. I can bring into the denominator, that is 2x power 2 minus 1 to the power plus 3. Question number 4. Find the derivative of f of x equal to cosine to the power 3x. So let me write this as cosine x to the power 3. So for our easy differentiation, I am writing the function like this. Now as per the rule, this will come front. So we have 3. Keep the inside function as it is, that is cosine x, you have to keep as it is. Then reduce the power by 1, that is 3 minus 1 will give you 2, multiplied by the derivative of the inside term. The inside term is cosine x. The derivative of inside term will be minus sine x. So my final answer will be minus 3 sin x and cosine squared x. Example number 5. Find the derivative of f of x equal to 3x power 2 plus 3x minus 1 to the power 4. So what I do, I have to take the power in front of the function, then we have to keep the term as it is, that is 3x power 2 plus 3x minus 1, then reduce the power by 1 will become 3 times, open another bracket, then derivative of the inside term. So 3x power 2 will become 6x and derivative of 3x will become 3. Then as I told you before, if you want you can multiply this and this. So 6x times 4 will give you 24x, 4 times 3 will give you 12, followed by the remaining term 3x power 2 plus 3x minus 1 to the power 3. Example number 6. Find the derivative of f of x equal to ln secant x. So what is my answer? My answer is the derivative of f of x will be f dash of x. Then my function is ln secant x. In our previous video, we have learned that the derivative of ln x is equal to 1 over x. Hope you remember, right? The derivative of ln x, d by dx of ln x is nothing but 1 over x. So using this idea, I can write the derivative of ln secant x as 1 over secant x. Then multiplied by the derivative of secant x. The derivative of secant x will be secant x tan x. So by cancelling secant x up and down, we will get f dash of x equal to tan x. Example number 7. We have already learned the product rule and quotient rule. Even in chain rule also we can apply the same ideas. See example number 7. Find the derivative of y equal to e power minus 5x cosine 3x. So now you have to consider e power minus 5x as u and cosine 3x as v. So what is product rule? U dv plus v du. So let me keep the term u as it is, that is e power minus 5x. Then dv. What is the meaning of dv? dv means the derivative of v. So derivative of cosine 3x will give you minus 3x sin 3x. Then derivative of 3x will be 3 plus v. What is my v? My v is cosine 3x. So let me keep cosine 3x. Then du. What is du? du is nothing but derivative of u. So my u is e power minus 5x. So the derivative of e power minus 5x equal to e power minus 5x followed by the derivative of minus 5x will give you minus 5. Now if you multiply this and this, will get minus 3 e power minus 5x sin x. Then the second term will become minus 5 e power minus 5x cosine 3x. Example number 8. Find the derivative of f of x equal to x power 2 ln 8x. So once again we apply the same idea. This time we have considered x power 2 as u, ln 8x as v. So let me keep u. The derivative of ln 8x will give you 1 by 8x, and then the derivative of 8x will be 8 plus v du. So that is ln 8x multiplied by the derivative of x power 2 will be 2x. Now by cancelling 8 and 8, by cancelling x and x, we have left with x in the first term plus 2x multiply ln 8x in the second term. So this is our final answer. Question number 9. Find the derivative of y equal to tan x plus sin x to the power minus 3. So by using chain rule, this minus 3 will come front. Then we have to keep the inside term as it is. And here we have minus 3 minus 1. This should be minus 4. Followed by the derivative of tan x will be secant squared x. The derivative of sin x will be cosine x. Example number 10. Find the derivative of f of x equal to tan inverse of square root of 3 minus x power 2. So we know that d by dx of 1 upon, d by dx of tan inverse of x is nothing but 1 over 1 plus x squared. Using this idea, we are going to solve question number 10. So now in place of x, we have this thing, square root of 3 minus x squared. Okay. So the derivative will give you 1 over 1 plus square root of 3 minus x squared the whole power 2 multiplied by the derivative of this one, square root of 3 minus x squared. This will give you 1 over 2 times square root of 3 minus x squared, followed by the derivative of the inside term minus x squared will give you minus 2x. By simplifying this, we will cancel 2 and 2. That will give you minus x by square root of 3 minus x squared. And in the first term, the square root and squared will get cancelled. We have 1 plus 3x squared. 1 plus 3 will give you 4. 4 minus x squared. Square root of 3 minus x squared in the numerator and minus x in the numerator. And we are at the end of the topic. So these are the exercise. We have given 7 problems here in the first column. We have also given you the answers in the second column. See you in the next video.